In the next exam question, a teacher is demonstrating the principle of conservation of linear momentum using two trolleys. The teacher first places trolley A and B some distance apart on a flat, frictionless horizontal surface, as shown in the diagram below. The mass of trolley A is 3.5 kg and that of trolley B is 6 kg. Trolley A moves towards trolley B at a constant velocity. The table below shows the position of trolley A for time intervals of 0.4 seconds before it collides with trolley B. 4.1 then asks us to use the table above to prove that trolley A is moving at a constant velocity before it collides with trolley B for a total of 3 marks. Now from the table we can see that we are given the change in position as well as the change in time for trolley A. We can therefore make use of the following equation to calculate the velocity of trolley A. And we repeat this for all 3 intervals. For all 3 intervals, we obtained a velocity of 0.5 meters per second. This therefore proves that trolley A was moving at a constant velocity before the collision. 4.2 asks us to state the principle of conservation of linear momentum in words. The principle of conservation of linear momentum refers to the following theorem, and in words it states that in the next part, it says that at time t is equal to 1.2 seconds, trolley A collides with a stationary trolley B. The collision time is 0.5 seconds, after which the 2 trolleys move off together. 4.3 says calculate the magnitude of the average net force exerted on trolley B by trolley A for a total of 6 marks. Now, in order to calculate the net force, we would have to have a look at Newton's second law in terms of momentum, which states that the net force is equal to the change in momentum over the change in time. The change in time here indicates the contact time of the collision, which is given as 0.5 seconds. The change in momentum we can evaluate by using either the values of A or the values of B. The V initial of A is calculated as 0.5 meters per second, which was the constant velocity of trolley A before the collision, but the final velocity of trolley A is also unknown. We would first have to calculate the final velocity of trolley A by applying the principle of conservation of linear momentum. Before the collision, we had the mass and the velocity of A and the mass of the velocity of B. After the collision, the 2 trolleys are stuck together and move off at the same velocity. Now remember that it was said that B was initially stationary, therefore its velocity is 0. Now we have enough information to solve the net force. Now remember, according to Newton's third law, the force that trolley B exerts on trolley A would be equal to the force that trolley A exerts on trolley B. Therefore, seeing as we're only looking at the magnitude, we can only write the final value of 2.21 Newton without having to indicate any direction.